Okay, so this is the first video in Chapter 4, and we're going to start off by talking about Newton's laws. Now I'm going to go really quick through this. There's a lot of resources on the internet. Wikipedia has an excellent article on Newton's laws. You can find it all over the place, so I'm not going to get into it really in terms of definitions. But there's 3 of them. And the first law is basically inertia. And some of you guys probably already know Newton's laws. It's basically an object in motion tends to stay in motion unless acted upon by an outside force. I'm going to talk about some examples of that in a little bit. 2 is the one that people basically never remember this as one of Newton's laws. And the reason why they never remember this as one of Newton's laws is because 1 and 3 are kind of things that, oh yeah, I got to memorize that for physics class. But 2 is a really important equation that we use all of the time. And so we're going to be using this equation all the time, and since we use it all the time and you think about Newton's laws as these things that you're supposed to memorize because the teacher said so, oftentimes people forget that number 2 is a very important Newton's law. Force equals mass times acceleration. So if you want to know what a force is, it's a mass times an acceleration. And then 3, I'm going to call that or let's say force pairs. That's probably a better way of putting it. That forces come in pairs. That right now I'm pushing down on the table and the table is pushing back on me. When I'm writing, I'm applying a force to the pen on the and the pen is applying a force back on me. The pen tip is applying a force on the paper. The paper is applying a force back on the pen tip. The paper is applying a force on the table. The table is applying a force back on the paper, etc., etc., etc. So that forces come in pairs. Okay, so I think with this I'm going to talk about just a few examples, and then we will get on to more specific examples in later videos. Okay, so 1, what I would like you to think about for 1 is a road bike on dry, level, good pavement in a peloton. Okay. This is a really good example of Newton's first law. Basically, the question is, how much force does it take to ride a road bike on dry level, good pavement in a peloton? A peloton is a whole big group of riders. And the answer is not much. Okay? We're going to introduce friction later in this chapter. And so, if you have a really nice road bike, everything has been done to sort of try to reduce friction to as low as possible. So it takes hardly any force to just spin the crank around. It takes very little force to spin the wheels. It takes very little force to roll the very hard, thin tires over the dry, level, good pavement. And then you say, well, what about air resistance? Well, if you're surrounded by 150 of your closest friends that are all riding down the same road at the same speed, they're kind of pushing the wind for you. And so if you're sort of sitting in the middle of that, you really just don't need to do anything. So basically, if you're riding a road bike in the middle of a group of people on dry level good pavement, you really don't have to put hardly any force into that whatsoever, because you just have a lot of momentum, you have a lot of inertia, and basically once you get up to speed, Newton's first law takes over, and an object in straight line motion tends to stay in straight line motion unless acted upon by an outside force. And we'll talk about that a little bit more in the next video. Let's see. We haven't really introduced the concept of mass, but I think you understand what we're getting at. We're going to measure mass. Okay, hit pause and take a guess. Mass is measured in. The correct answer is kilograms. And if you go back way to one of my very early videos, I believe for chapter 1, we talked about how 1 kilogram is approximately 1 liter of water. So if you think about 1 liter of water, that's about 1 kilogram. Okay, so then we're going to talk a lot about F equals ma here in a little bit. But you know, quick sort of thing is, if I have a ball with mass of 200 grams dropping with acceleration equal to negative 9.81 meters per second squared, then my F is 0.2 kilograms. Look how I just did that conversion really quickly. Negative 9.81 meters per second squared, and I'm going to get 1.96 newtons. Ooh, there's something we got to talk about there in the future, but that's a newton. So I'm going to complete that, and I'm going to say 1 newton, that's my unit of force, is equal to 1 kilogram meter per second squared. So after a while we get sick of saying 1 kilogram meter per second squared, 1 kilogram meter per second squared, 1 kilogram meters per second squared, so we eventually come up with a simpler shorthand way of saying kilogram meters per second squared, and we say Newton. But people really often forget to make that connection, that 1 Newton is 1 kilogram meter per second squared. Very important for us to talk about later. Then if I have a little box of batteries here, if I apply a force on the batteries and move them, every single time I apply a force on the box of batteries, it's going to apply an equal and opposite force back on my finger. And that's Newton's third law. That, you know, there's millions and millions of examples all over the place, but if I apply any force on any object, then that object applies a force back on me. And so that is Newton's third law. Okay, so that's this, and we're going to come back and we're going to talk about Newton's first law in the next video.